Hello students, welcome back to my YouTube channel Rahman Chemistry Coaching Academy. Today we are going to explain and discuss BAEYER strain theory. This is our lecture number 13 in the series of lectures on stereochemistry. Before discussing BAEYER strain theory, first we need to know about cyclic compounds. Cyclic compounds are cycloalkanes are saturated hydrocarbons in which the carbon atoms are connected to each other in a cyclic ring fashion. The general molecular formula of cycloalkane is CnH2n and thus have two pure hydrogen atoms than the alkane with general molecular formula CnH2n plus 2. The example of cycloalkanes are cyclopropane, cyclobutane, cyclopentane, cyclohexane, cycloheptane and cyclooctane, etc. If the cycloalkanes are subjected to ring opening reactions, it can be observed that cyclopropane can undergo ring opening reaction very easily. That is, cyclopropane can react with bromine or chlorine in dark conditions to undergo ring opening reaction and give this addition product. Cyclopropane can also react with hydrogen bromide to undergo ring opening reaction and give this addition product. On the other hand, cyclobutane do not undergo ring opening reaction at normal condition but rather give ring opening reaction at some drastic condition. While higher cycloalkanes such as cyclopentane, cyclohexane, cycloheptane and cyclooctane etc. do not undergo ring opening reaction at any conditions. So to answer these strange behavior of cycloalkanes towards ring opening reaction, BAEYER proposed a theory known as BAEYER strain theory or angle strain theory. BAEYER strain theory or angle strain theory was proposed by Dr. Adel Baer, a German chemist, in 1885, for which he was awarded Nobel Prize in Chemistry in 1905. According to Van Hoff and Liebel model, the geometry of the carbon atom is tetrahedral in nature with bond angle of 109 degree 28 minutes. Baer used this model and proposed his theory in the background of this model, and his theory is known as BAEYER strain theory. The main assumptions or postulates of the BAEYER strain theory are: number one, the carbon atom is tetrahedral in nature and the angle between the carbon bonded to a pair of carbons atoms should be 109 degree 28 minutes or approximately 109.5 degree. The second postulate of the BAEYER strain theory is that the deviation from this bond angle, that is 109 degree 28 minutes or 109.5 degree, can cause internal strain in the molecule known as angle strain. The third one postulate of the BAEYER strain theory is that cyclopropane and cyclobutane are planar in nature, while other cycloalkanes rings are polygons. That cyclopropane is an equilateral triangle, cyclobutane is a square, while other cycloalkane rings are polygons. The fourth one postulate of the BAEYER strain theory is that the stability of the cyclic compounds or cycloalkanes depend upon the angle strain, and there is an inverse relationship between the stability of cycloalkanes and angle strains. That is, the stability of cycloalkane decreases with increase in angle strains and vice versa. The angle strain can be calculated by using the formula D is equal to half 109.5 degree minus alpha, where alpha is the bond angle or desired bond angle in various cycloalkanes. It should be noted that the distortion of the bond angle is assumed to be equally shared between two bonds, where the angle strain is the angle difference between the desired angle and the actual angle. Applying this formula, that D is equal to half 109.5 degree minus alpha, used for calculation of angle strength in various systems. We can easily calculate angle strengths for uh, cyclopropane, cyclobutane, cyclopentane, cyclohexane, cycloheptane, and cyclooctane, etc. Look at to these structures. In these structures, the carbon atoms are sp3 hybridized with internal bond angle of 109.5 degree. Due to strain in these cycloalkanes, the bond angle deviates from the normal tetrahedral bond angle of 109.5 degree. The more the strain in the ring, the more the bond curve. The lower the strain in the ring, the greater the bond are straight. Now to calculate the angle strain per cycloalkane, first we have to find out the interior angles of cycloalkanes. The interior angles of cycloalkanes can be calculated by using the formula that interior angle of cycloalkanes are polygons is equal to 180 minus 360 by n, where n is the number of sides of cycloalkanes are polygons. Using this formula, the interior bond angle of cyclopropane calculated is a 60 degree. The same formula can also be applied to calculate the interior bond angles of other cycloalkanes, that is cyclobutane, cyclopentane, cyclohexane, and cycloheptane, etc. After finding the interior bond angles alpha of cycloalkanes, their value is put in to the formula for calculation of angle strength, that is d is equal to half 109 degree 28 minutes minus alpha, and thus we can easily calculate the angle strengths for various cycloalkanes as shown, that is cyclopropane, cyclobutane, cyclopentane, cyclohexane, cycloheptane, and cyclooctane, etc. So thank you for watching my video lecture. The remaining part of Bayes strength theory will be discussed and explained in my next video lecture, that is lecture number 14. If you like this video, then please like, share, comment and subscribe my channels for more videos.